cos c minus cos d formula I have applied. That means 2 sin c plus d by 2 sin d minus c by 2. We get this form. 1 plus c by x minus c. On simplification, it will be c will be cancelled at the numerator. Then there will be x. Good morning. Welcome to btosacademy. Welcome to my maths class. Today I am going to work out sums on the topic derivatives. Actually, already I have discussed related matters, theories, formula, etc. of derivatives for both first order and second order. Now, I have decided today I shall work out few sums from board papers. I have already written 2 sums on the board. I shall work out one by one. First one, x is equal to under square root a to the power sin inverse t, y is equal to root over a to the power cos inverse t. Then you have to show that. First of all, learners, students, you follow. Apparently, this is parametric form, x in terms of t, y in terms of t. If you first find dx dt, then dy dt, it will be quite complicated. After that, we note that sin inverse t, cos inverse t both exist, and we have to think that relation of inverse trigonometric function, which is sin inverse t plus cos inverse t is equal to pi by 2. That is why also another thing, square root symbols are there. If I first remove those square root symbols, then we multiply, and as the basis in both cases a, then powers will be added. Then we can apply that formula or identity, sin inverse t plus cos inverse t is equal to pi by 2. Now follow. X is equal to a to the power sin inverse t. Therefore, x square is equal to a to the power sin inverse t. Y is equal to a to the power cos inverse t. Therefore, y square equal to a to the power cos inverse t. Now, a in both cases a is base. Now, if I multiply, then the result will be a to the power sin inverse t plus cos inverse t. Therefore, x square plus y square equal to a to the power sin inverse t into a to the power cos inverse t. That is equal to a to the power sin inverse t plus cos inverse t. That is equal to a to the power pi by 2. Therefore, finally we get x square, I have taken product, x square into y square is equal to a to the power pi by 2. Now we have to find dy dx, differentiating. With respect to x, u into v form, x square into d dx y square plus y square into d dx x square is equal to d dx a to the power pi by 2. Therefore, x square. Now this is y square. Therefore, we have to use chain rule. We mentally do that. D dy of y square, that is 2y into dy dx plus y square into 2x, and this is constant, therefore derivative will be 0. Now we keep dy dx term on the left side. 2 x square y into dy dx is equal to minus 2x y square. 2 cancelled, therefore dy dx is equal to minus x y square by x square y minus y by x. Follow? After getting this relation, x square into y square equal to a to the power pi by 2, we differentiate both sides with respect to it, with respect to x. This is u into v form, therefore we have applied u into derivative of v plus v into derivative of u, that is equal to ddx of the right side. Right side is constant, therefore right side derivative of right side will be 0. Then after simplification we are getting dy dx equal to minus y by x. Proved. Hence, for learners, you have to understand which method is to be applied. First, you read the sum and understand what process is to be adopted. You see, already I have mentioned, I repeat, apparently this is parametric form, but if we try that method, that means dx dt first, then dy dt, then it will be very much complicated. There we have to use this process. Then, now second sum. Fx equal to a plus x by b plus x whole to the power function fx is this. First we know that base involves variable, power also having variable x. Therefore, we have to apply here logarithmic differentiation. Taking log of both sides, mention base is e. Log fx is equal to, if I take log of this form, base power will be taken first in front, a plus b plus 2x into log of a plus x by b plus x. Now log u by v form, therefore we can write a plus b plus 2x log of a plus x minus log of b plus x. Now we differentiating with respect to x. Left hand side is log fx. We have to apply the chain rule. First of all, we think fx as u, that means log u equal to fx. Derivative of log u with respect to u will be 1 by u, that means 1 by fx into du dx, that means derivative of fx dx of fx. Let me write once. Now this is u into v form, therefore a plus b plus 2x ddx of whole plus this into derivative of this. Again, this means this one, therefore I write that form into derivative of this expression a plus b plus 2x. Variable is x, other symbols that is a, b are constants, therefore derivative will be 2. Now I simplify a plus b plus 2x. Now derivative of this part, ddx of this one, again chain rule, log u form, that is 1 by u, 1 by a plus x into derivative of a plus x, that will be 1 minus 1 by b plus x into 1 plus 2 log a plus x by b plus x. Ddx of fx, that is f dash x. Therefore, f dash x is equal to fx into this whole expression, fx into a plus b plus 2x. Now we simplify this one. A plus x, b plus x, numerator will be b plus x minus a minus x, x cancelled, plus 2 log a plus x by b plus x. Now we have to find f dash 0. For that, if 0 is needed, after writing this one, we find here if 0, that means putting x equal to 0, the value of fx, that will be equal to x0 a by b whole to the power a plus b. Now I write here, after this step, f dash 0 is equal to f0 all into a plus b b minus a divided by ab plus 2 log a by b. See this. Now we compare with this result, final result. Two log a by b plus a plus b into b minus a, that means b square minus a square by ab into f0. Already we have found f0, this one, thus we have got the result f dash 0 proved. A bit long. You have to be patient, follow the steps. Actually I am working out to give you confidence so that you can work out yourself. My suggestion, you work out lot of derivatives. That is very essential in case of higher mathematics, also in case of engineering stream. Thus the second sum is solved. Now third sum, x equal to this, y equal to this, we have to find d2y dx2 at theta equal to pi by 2. First we find dy dx, x is equal to 2 cos theta minus cos 2 theta, and I find side by side 2 sin theta minus sin 2 theta. Parametric form, here I find dx d theta, dd theta of 2 cos theta, constant 2, derivative of cos theta minus sin theta, minus cos 2 theta minus sin 2 theta, taking 2 theta as u, chain rule applied, cos u minus sin u into dd theta of 2 theta means 2. We simplify that, 2 sin 2 theta minus 2 sin theta. Now this is 2 into 2 sin theta cos theta minus 2 sin theta. Actually I am simplifying. 2 sin theta is the common factor, 2 cos theta minus 1 dx d theta equal to this. Then dy d theta, 2 derivative of sin theta is cos theta minus cos 2 theta, sin u form cos u into du d theta will give 2 cos theta minus 2 cos 2 theta. 2 is common factor, 2 cos theta minus cos 2 theta. Therefore dx is equal to dy d theta by dx d theta. We put the values. 2 cos theta minus cos 2 theta by 2 sin theta 2 cos theta minus 1. 2 cancelled. Now I put here cos form, cos 2 theta, cos form, cos theta minus 2 cos square theta minus 1. Sin theta 2 cos theta minus 1. Therefore, dy dx is equal to 1 plus cos theta minus 2 cos square theta by sin theta 2 cos theta minus 1. Now this expression can be resolved into factors. I do that on the right space. 1 plus cos theta minus 2 cos square theta is equal to 1 plus 2 cos theta minus cos theta minus 2 cos square theta. That is equal to 1 plus 2 cos theta minus cos theta within brackets 1 plus 2 cos theta 1 minus cos theta into 1 plus 2 cos theta. Now to solve this sum, if we take this form, it is becoming complicated. We keep this form and apply the transformation formula here. That means dx d theta is finally this form, 4 sin theta by 2 cos 3 theta by 2, and dy d theta cos c minus cos d formula I have applied. That means 2 sin c plus d by 2 sin d minus c by 2. We get this form. Therefore, to calculate dy dx, we apply this form. Dy d theta is equal to 4 sin theta by 2 sin 3 theta by 2 by 4 sin theta by 2 cos 3 theta by 2. Now these two cancelled. Therefore, tan of 3 theta by 2. Therefore, in that case, dy dx will be tan 3 theta by 2. Therefore, dy dx at theta equal to pi by 2 is equal to 10 3 pi by 4. 3 by 2 into pi by 2, 3 pi by 4. 10 of pi minus pi by 4 is equal to minus 1. Now we have got dy dx at theta equal to pi by 2. We have to find d2y dx too. Dy dx equal to 10 3 theta by 2. Therefore, d2y dx2 is equal to ddx 10 3 theta by 2 dd theta. Since variable is theta, therefore chain rule applied. Dd theta of tan 3 theta by 2 6 square 3 theta by 2 into dd theta of 3 theta by 2, that is equal to 3 by 2 into d theta dx. We have got dx d theta, this one. Therefore d theta dx means 1 by 4 sine theta by 2 cos 3 theta by 2. That is equal to 3 by 8 into 1 by sine theta by 2 into cos cube 3 theta by 2. d2y dx2 is this one. Therefore d2y dx2 at theta equal to pi by 2. Therefore d2y dx2 theta equal to pi by 2 is equal to 3 by 8 1 by sine pi by 4 means 1 by root 2 into cos cube 3 theta by 2. Let us calculate that here. Cos 3 pi by 8 pi by 4 cos of pi minus pi by 4, that means minus 1 by root. Therefore it will be minus 1 by root 2 whole cube. If we simplify, it will be minus 3 by 8 into root 2 whole to the power 4. That means 4. A bit complicated. First of all, we have found dx d theta and keep the result in this form so that we can apply transformation formula. Then dy d theta. After getting this form, applied transformation formula, then we have got dy dx. Applying the formula dy d theta divided by dx d theta, on simplification it is tan 3 theta by 2 dy dx tan 3 theta by 2. Then dy dx, we have found the result, though it is not needed in this case. Result is minus 1 dy dx at the point theta equal to pi by 2. Then we have found d2y dx2. This is theta form, therefore we have to apply chain rule like this, and putting the values we have got this result. Then at the point theta equal to pi by 2, the result after simplification is minus 3 by 2. Now x equal to this one, I write first. Now this expression in t is to be simplified first. Since there is cos inverse, therefore we have to express in cos form. Now I follow this method. Let t equal to cos theta. Actually, in multiple angle we have a formula. I first deduce that. Therefore, eight cos square theta plus 1. From the first two, I take 8 cos square theta, common factor, cos square theta minus 1 plus 1. Now, if I take minus 1 common factor, it will be 1 minus cos square theta plus 1. 1 minus 8, this is sin square theta, cos square theta. That can be written as 1 minus 2 into 2 sin theta cos theta whole square. That is equal to 1 minus 2. This is sin 2 theta, that means 2 sin square 2 theta, which is cos 4 theta. Therefore, x equal to cos inverse cos 4 theta, that is equal to 4 theta. This is very good thing. Students are to deduce this one. Actually, cos 4 theta has this form. If we deduce in the reverse order, then after expressing in cos form, we get cos 4 theta equal to this one. I have deduced here. Therefore, we have got x equal to 4 theta. Now, for this one, y will be equal to sin inverse 3 cos theta minus 4 cos cube theta. But in multiple angle form, sin 3 theta equal to 3 sin theta minus 4 sin cube theta. I first write in this form 3 sin pi by 2 minus theta minus 4 pi by 2 minus theta. cos theta is equal to sine of pi by 2 minus theta. Now I get that form 3 sine phi minus 4 sine cube phi, where phi equal to pi by 2 minus theta. Therefore, sine inverse sine theta is this angle 3 pi by 2 minus 3 theta. Pi by 2 minus 3 theta. Now we can find easily dx theta and dy d theta. Therefore, dx d theta equal to x equal to 4 theta. Therefore, dx d theta equal to 4 and dy d theta. This is constant. Therefore, derivative will be 0 minus 3. Therefore, dy dx, I apply formula dy dx dy d theta by dx d theta, putting the values minus 3 by 4. This is the answer. Dy dx is equal to minus 3 by 4. Now this problem, y equal to log of tan x by 2, then we have to prove this one. Y is equal to log of tan x by 2. Therefore, dy dx, you can mention here differentiating with respect to x. Dy dx equal to, this is log form, log of u, that means 1 by u into du dx cos x by 2 by sin x by 2 into tan u form sec square x by 2 into derivative of x by 2 half. Therefore, dy dx is equal to 2 sin x by 2 cos x by 2 sec square x by 2 means sec x by 2 1 by 2 sin x by 2 cos x by 2, that is equal to 1 by sin x. Thus, on simplification, dy dx is equal to 1 by sin x. Therefore, sin x into dy dx is equal to 1. After getting dy dx, that is first order derivative, and after simplifying we get this one, again differentiating with respect to x, u into v form sin x into derivative of dy dx, that means d2y dx2 plus derivative of sin x, that is cos x into dy dx, that is equal to 0. Now we see this is the result. sin x into dy dx 2 plus cos x into dy dx equal to 0. Good. Problem number 6. I start here. 6. First of all, I see this is a large expression. First of all, we have to simplify that one. There are 3 fractions plus 1. We cannot differentiate directly with respect to x. First of all, we simplify that. Y is equal to, we simplify step by step form. 1 plus a by x minus a. If we simplify x minus a plus a, that means numerator will be x plus bx by x minus a into x minus b plus cx square x minus a into x minus b into x minus c. Now I take these two, or y is equal to LCM of the denominators, x minus a, x minus b, then x into x minus b plus bx plus cx square x minus a into x minus b into x minus c. Now, if we multiply x minus b by x, product will be x square minus bx, dx will be cancelled, or y is equal to x square by x minus a into x minus b plus cx square by x minus a, x minus b, x minus c. This simplification is very important. Now x square, x minus a, x minus b are common factors. We take those out. One plus c by x minus c, that is equal to x square x minus a, x minus b, x minus c. 1 plus c by x minus c, on simplification it will be cc will be cancelled at the numerator, then there will be x. Finally, we get y equal to this. Y is equal to x cube by denominator x minus a, x minus b, x minus c. Product of these two, these three, sorry. Then we have to show this one. Already I have mentioned earlier, we find here the function is of the form numerator by denominator, and numerator denominator both are involving the variable x. Therefore, we apply here logarithmic differentiation. It will be very much useful if we apply here logarithmic differentiation. taking log of both sides base e, left hand side log y, right side u by v form, therefore log x cube minus log x minus a into x minus b into x minus c, 3 log x minus product, therefore log of x minus a minus log of x minus b minus log of x minus c. Thus we get log y equal to this. Now we differentiating with respect to x. Left hand side y, function of y, therefore we will apply chain rule, 1 by y dy dx is equal to 3 log x, derivative will be 3 by derivative of log x, that is x, minus log u form 1 by x minus a, derivative of x minus a is 1, therefore this 1 by x minus b minus 1 by x minus c. Now we have to show this one, and here we get 3 by x. Now you see, I take 1 by x with the first one, next 1 by x with the second one, and the third one is taken with this one. Now we simplify. For this one, denominator will be x into x minus a minus x plus x into x minus b minus x plus x into x minus c minus x. These x's are cancelled finally, and x is common factor from the denominator, therefore dy dx. I take this y on the right and this x, y by x minus a. If I multiply both numerator and denominator, it will be a by a minus x. I apply that on these two also. A by x minus a plus b by, it will be a minus x. B by b minus x plus c by c minus x. Now we see we have got the result. For this one, you must be patient and very much careful. We follow the process. First of all, we have simplified this large expression by addition of fractions. Of course, step by step. I have not done at a time. First, I have simplified the first two, then the result is with the third one, then with the fourth one. Finally, we have got y is equal to x cube by this one. Then, as per discussion, here it is useful to use logarithmic differentiation, or we have to use here logarithmic differentiation, and we have got after log this one. Then we have differentiated and again simplification. Very much interesting one. Therefore, this sum is solved. Next, these sums. First of all, sin y equal to this. First, you note this xy mixed form, but in case of derivative, the right hand side is x. First of all, you want to follow derivative is expressed in terms of x and constant. For that, from the given relation, if we express y in terms of x, then it will be easier. Follow. Sin y is equal to x sin of a plus y. Now, I apply sin a cos y plus cos a sin y. Sin y term is there, therefore I take sin y term on the left, or sin y minus x sin y cos a is equal to x sin a cos y, or 1 minus x cos a into sin y is equal to x sin a cos y. Therefore, sin y by cos y is equal to x sin a by 1 minus x cos a. Therefore, tan y is equal to x sin a by 1 minus x cos a. Y in terms of x, tan y of course. Then I differentiating with respect to x. Left hand side is y, function of y, therefore chain rule is applied, dd y tan y into dy dx. Right hand side u by v form 1 minus x cos a whole square, v square, then v into derivative of 1 minus x cos a into derivative of x sin a minus, I write at the top here, x sin a into derivative of 1 minus x cos a. Derivative of 1 is 0, minus x cos a, that means minus cos a. Minus cos a, or 6 square y into dy dx is equal to 1 minus x cos a whole square sin a minus x sin a cos a minus minus plus x sin a cos a. These two cancelled. Therefore, sin a 1 minus x cos a whole square. Therefore, dy dx is equal to sec square y will be at the denominator, sin a by sec square y into 1 minus x cos a whole square. Now sec square y is there, value of that is to be found out. We have tan y, from that sec square y is equal to 1 plus tan square y means this one, x sin a 1 minus x cos a whole square. We simplify 1 minus x cos a whole square 1 plus x square cos square a minus 2x cos a plus x square sin square a. Now if we take these two together, then it will be x square, means 1 minus 2x cos a plus x square by 1 minus x cos a whole square. This is value of sec square y. We put this value, we call it say a. Is equal to sin a by, this will be placed at the denominator, therefore at the numerator it will be right 1 minus x cos a whole square by 1 minus x cos a whole square into 1 minus 2x cos a plus x square, x square. Now these two are cancelled. Finally, sin a by 1 minus 2x cos a plus x square. One thing I have to mention, that given this condition, sometimes other forms are also given. I have solved this one. You will find in your book other forms also. Now sum number 8. P into b to the power a equal to c. AC are constant. AC constants. Since product As well as power form is there, we have to apply here logarithmic differentiation. Taking log of both sides. This of course will be log p into p to the power a is equal to log c, or log p plus a log v equal to log c. Now we differentiate with respect to v. With respect to v, log p, function of p, chain rule 1 by p into dp dv plus a log v, derivative of log v with respect to v is 1 by v is equal to 0, or 1 by p dp dv is equal to minus a by v. Therefore, dp dv is equal to minus ap by v. Again differentiating with respect to v. Left hand side dp dv, therefore it will be d2p dv2 is equal to u by v form, minus a is there which is constant, therefore I take minus a outside, then apply u by v form, v square into v into derivative of p with respect to v, therefore it will be dp dv minus p derivative of v with respect to v, that is 1, I call it 1 a, or d2p dv2 is equal to minus a into v dp dv. v dp dv, from here we are getting value minus ap minus p by p square. Here I mention using from a. Minus 1 is common factor, that means numerator a into a plus 1 p by v square. Therefore, v square into d2p dv2 is equal to a into a plus 1 whole into p. Proved. Y equal to this, we have to prove that y equal to sine of 2 sine inverse x. Function of function form, therefore dy dx is equal to sine theta form cos theta, that means cos of 2 sine inverse x into d dx of 2 sine inverse x. Cos of 2 sine inverse x into 2 by under square root 1 minus x square. Therefore, I multiply it with the left. Now, if we square both sides, then square root will be removed. Square it. One minus x square into dy dx whole square is equal to 4 cos square 2 sine inverse x. Cos square theta form, that means 4 1 minus sine square 2 sine inverse x. Now, if we remove brackets, it will be 4 minus 4 into sine square 2 sine inverse x means this form, that means it will be y square. Finally, we have got 1 minus x square whole into dy dx whole square equal to this one. Now we differentiate again. Note this step. If we don't square, then it will be square root of 1 minus x square, and if we differentiate this one, it will be some complicated one. If we square, then it will be cos square, then in place of cos square theta form, we put 1 minus sine square theta. Then it will be quite easier. Again differentiating. This is u into v form. Therefore, 1 minus x square into derivative of this 2 dy dx into d2y dx2 plus derivative of 1 minus x square is minus 2x into dy dx whole square. For right side, 4 constant is 0 minus 4 2y dy dx. See this. We have differentiated. Left hand side is of the form u into v. Therefore, u into derivative of this one, u square form 2u into du dx, that is why 2 dy dx into d2y dx2 plus this into derivative of this. You see, on the right side 4 constant, therefore first one is 0, then minus 4 into derivative of y square, that is 2y dy dx. Now we find dy dx is a common factor, also 2, or 1 minus x square into d2y dx2 minus x dy dx is equal to minus 4 1. We have got that form, or 1 minus x square d2y dx2 is equal to x dy dx minus 4y proved. One thing I have to mention, that we are dividing this step by dy dx. You mention that dividing both sides by dy dx, and we consider that non-zero. It will be better if you mention that, hence the sum is solved. This sum, you see, x is equal to 1 by z, y equal to fx, and the relation to be proved is this one, d2y dx is equal to 2z cube into dy dz plus z to the power 4 d2y dz. Now, dy dz, d2y dz2 are there, and y equal to fx, y function of x, and x equal to that. I write that first, given y equal to fx and x equal to 1 by z. From it, dx dz equal to minus 1 by z square. Now dy dz is to be found out. Now dy dz is equal to, since it is function of x, therefore ddx fx into dx dz chain rule, that means this is dy dx into dx dz minus 1 by z square. Follow this step. I have found dy dz. Since dy dz, d2y dz2 are there. Now, or I multiply z square into dy dz is equal to minus dy dx. Now I differentiate again with respect to z. Again, differentiating with respect to z. UV form, z square into d2y dz2 plus dy dz into 2z. This is equal to ddz minus dy dx. This is function of x. We are differentiating with respect to z. Chain rule, minus d2y dx2 into dx dz. Function of x, we are differentiating with respect to z. We have to apply chain rule, ddx of this whole, that gives minus d2y dx2 into dx dz. Now I put the value of dx dz from here, minus d2y dx2 minus 1 by z square, multiplication. Now I multiply both sides by z square, then we get z to the power 4 d2y dz2 plus 2z cube dy dz is equal to d2y dx2. d2y dx2 equal to this. You can now write the final step as d2y dx2 is equal to z2z cube dy dz plus z to the power 4 into d2y dz2. Therefore, this sum is solved. Now, students, learners, already I have solved so many sums on derivatives, both first order and second order. Your task is you practice a lot to master yourself of differentiation. Hence, I finish this chapter here, the derivatives.